Welcome back, guys. So here I'm going to demonstrate how to configure auto RP and how to configure candidate RP followed by mapping agent. So I have taken a 7 set of routers, router 1 being the sender and router 7 being the receiver. And this is a pre-configured lab where I have enabled IP multicast routing on all the routers, and I'm using EIGRP as an underlying protocol for the end-to-end connectivity. And even on the all the interfaces, I have enabled PIM as well. So I'll demonstrate you how to configure auto RP, what we have discussed in our theory session. See, so in the previous lab, I have configured router 3 as the rendezvous point. So we have to remove the PIM configuration from all the devices. What I mean to say, uh, we have to remove this config from all the devices like this. Even from the router too, I have to remove the previous config. And in the next step, I should be enabling auto RP listener feature in all the devices. And to do so, we have to run the command ippim auto RP listener. So with this command, I have enabled auto RP listener feature, and I have to run this command in all the devices. So basically, I have to remove this RP. Even in the router 4, we have to enable listener features. Now in router 3 or router 1, which is being the sender, I need to clear all the IP mroute table as well for the fresh entry. And I believe it would be good idea to clear mroute table from all the devices. So from the sender, which is the router 1 in the topology, we'll try to generate some ping packet for the group 224.1.1.1, and we'll see whether we are getting ping response or not. So I believe probably we'll do repeat 10. And on the router 3, I'm going to check whether we are getting any data or not. See, there aren't any entry of 224.1.1.1, and even ping is failing. And from the receiver, what we do, we try to join the packet for the group, and then we will test it. We'll check the mroute table on the router 3, still no data, and we'll try to ping it from the senders, and ping should be failing. The reason being there aren't any rendezvous point or the RP router configured yet. So the next step would be I'm going to configure router 3 as a candidate RP and as well as mapping agent. So to do so, we have to run the command ippim send RP announce, and we are making loopback 3 as a to send announce packet, and then we have to run scope 255 interval 1. So at every 1 second, it will exchange some packet. And to configure mapping agent, we have to run the command show ip pim rp discovery, and we'll make loopback 3, then scope 255 interval 1. And possibly on router 2 also we'll run the same command and we'll configure as a candidate RP, and then we will see the election. So on router 2 we'll configure the same thing. We'll make here loopback 2. Now we are coming back to router 3 to check which router is elected as a candidate RP, and to check that we have to run the command show IP pim RP mapping. We need to wait for some time to get the data. See here it is showing this system is an RP selected as a RP, and the loopback 3 is the RP which we have configured. Same command we will run on router 2 as well. See loopback 3 RP 3.3.3 is elected in RP address, elected as a auto RP, and for the router 2 loopback IP which is 2.2.2 is been secondary, is not elected as a RP. So router 2 and router 3, they are willing to become a candidate, but out of those two, router 3 has been elected. See from the logs from router 2 also you can see RP 3.3.3 been selected as auto RP, and 3.3 is the RP of the 3.3.3 is the loopback 3 IP of router 3. So I have demonstrated how router 2 and router 3, they both are willing to become a candidate, but mapping agent had selected router 3 as a RP. The reason being the router 3 loopback IP is being the highest compared to the loopback IP of router 2. That's the reason it's been elected. Now coming back to router 7, which is the sender, will generate some packet and will check the mroute table on router 3 which been elected as a RP. Yes, currently the table is populated and we can see the two entry for the group 224.1.1.1, 1.1.1 which shows the loopback IP of the sender, and this is the interface IP because the data are coming from the different sources and the table is populated. Now we can use the ACL as well. So possibly on router 2 to use the ACL, before that I'll show you something. Show IPP mapping. Currently this group 224.0.0.0 slash 4 is being data is forwarded. So what we'll do, we'll write one ACL, we'll configure one ACL. Okay, to configure the ACL, what we need to do, One is the ACL name. So what we are going to do, we'll access list 1, permit 225.1.1, and rest of the groups are denied. So now what we'll do, we'll generate a packet for 225. Before that, we need to check the RP mapping. Now we need to ping it for 225, probably with few packets only. Now we'll check the M route table for 225. See, we are getting the S comma G entry for 225.1.1. Similarly, if we try to ping it for 226, and we'll check the table for 226. See, the currently outgoing interface is showing null, so probably we have to join the packet from the receiver side. We'll check it. See, if you compare the logs from the previous one, see currently the outgoing interface is null, and now the outgoing interface is showing 0/1. And for the same ACL, we'll try to edit the ACL. We have denied 226.1.1.1, and even we'll do ICMP join from for the this group, and we'll try to ping the packet. So it is showing tunnel is down, so definitely it is not pingable. Check the mroute table. See, group is not found. And if we do show IP pim RP mapping, but data is coming, we need to wait for some time. We need to wait for some time. See, for the group 224.0.0/4, RP has been selected as 2.2.2, which means that the router 2 loopback IP has been selected as rendezvous point via auto RP method, and the for group 225.1.1, this is the RP, and for 226, this is also the RP, but it has been denied with the ACLs. So that's the reason it won't came back up. See this icon. So this is overall a scenario how you can configure candidate RP, how you can configure mapping agent, and if there are multiple router who are willing to become a candidate, So based on the highest RP address, the mapping agent will elect which device or which devices will be becoming the candidate RP, and how we can use ACL to filter the traffic based on the source.